Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, the official guide to the revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 122. Please turn to it. Page 122, and today is our lesson number 257. 257. The problem that we are about to solve actually is not the exact same problem that you see on page number 122, but a modified or a second version of it, a bonus problem if you will. Here's what's going on. This by the way is the same problem. Actually, this is not the problem that we did on day number 15 and 16. On day number 15 and 16, all of these problems have already been done here. This problem that you see on page 122 is something that I did on day number 15 and 16 long time ago in a greater depth, in more detail. Yesterday we did the same problem on page number 256 at a little bit of a faster pace, and this problem actually is a bonus problem. The difference is that in the original version that is given to you in the book is that we are told that there are twice as many people in department X as there are in Y. In this version there are 3 times as many, there are thrice as many people. The average for department X is $15,000, the average for department Y is $25,000, and the question is which of the following is the overall average. Now if you have not watched yesterday's video, date 256, watch that video first, stop this video right now. Watch 256 first, understand how it is done, and try to do this problem yourself first before you watch the solution. You will get more out of it. So here we go. So what we do is, we ask ourselves, we ask ourselves, what would the overall average be if there were exactly thrice as many people? We are told that there are more than thrice as many people in X, but let's ask ourselves, what would the overall average be if there were exactly thrice as many in X? But that's pretty straightforward. We just have to take the weighted average. So we know the average, we are told the average for department X is 15,000 people, $15,000, and if there are thrice as many people, so we have to take the average, weighted average, 15 times 3, plus the average for the other department is 25, and we divide by 4. Divide by 4 because here we have a weight of 1. So 3 plus 1, we have 4 people, so that's why we divide by 4. For out of every 4 people, 3 of them belong to department X, 1 belongs to department Y. And in that case, the question is, what would the overall average have to be? Let's find out. Let's find out, shall we? 15 times 3 is 45. 25 times 1 is just 25 over 4. So there's 60, 70, 70 divided by 4. How much is 70 divided by 4? Let's find out, shall we? How many 4s in a 7? 7 has only one 4. 7 has only one 4. 7 has one 4. The remaining 3 goes and joins this guy, becomes 30. And how many 4s in a 30? 30 has 8 4s. 8 4s are 32. No, that's not going to work. 7 4s. 7 4s are 28. 7 4s are 28. And the remaining 2 is what we have here. So it's 17 and 2 quarters, which is 17 and a half. 17 and a half. So what we find is that if there were exactly thrice as many people, the overall average would be 17,500. But because there are more than thrice as many people, it pulls the average down. Because there are more than thrice as many, in X, it pulls the average down. What that tells is that the overall average, whatever it is, has to be less than 17.5. That implies, therefore this implies that the overall average whatever it is must be less than 17,500. Well, has to be less than 17,500, but it can be 17, it can be 16. So what we're claiming is that these two are possible, A and B are possible, but all the others are not. The overall average cannot be anything more than 17,500. What we're going to do now is exactly what we did yesterday, is to ask ourselves, what would the exact ratio have to be of the number of employees in department X versus the number of employees in department Y in order for the overall average to be exactly $16,000, in order for the overall average to be exactly 17,000. Let's find out, shall we? So, what we're asking ourselves is this: what would the exact ratio have to be in order for the overall average to be exactly 16,000. And then we'll ask ourselves the same question for 17,000. So let's find out. So we have 15,000 is the average for one department, 25,000 is the average for the other department. So that's our ratio. The weight that we are assigning to department X is W. And for every W people, for every given number of people in department X, we have the average of 25. For every one person in department Y, we are claiming that there are W people, which is the weight, the ratio if you like. And that would be the W plus the 1. And that average has to be 16,000. This is the part that I'm describing here. If you had trouble understanding what I'm doing here, if you did not follow me, I'm going at a faster pace. I'm cognizant of the fact that you may have trouble understanding it if you have not watched the previous video. As I told you already more than once, watch day 256, and better yet, watch day number 15 and 16, where I go into a lot more detail to help you understand what's going on here. So, let's cross multiply here. So we get 15W plus 25 equals 16W plus 16. So subtract 15W from both sides and we find out that W equals 25 minus 16, which is 9. Voila. We are claiming that the overall average, we are claiming that the ratio would have to be 9 to 1 in order for the overall average to be 16. Let's verify it, shall we? We're going to quickly verify it. So we're claiming this W is 9. So put 9 in here. For every 9 people that we have in department X, we need to have 1 person in department Y, which means we have a total of 10 people. And that amount has to be 16,000. Let's see if it is. 15 times 9, how much is 15 times 9? How the hell do I know? 15 times 10 is 150, so 150 minus 15 is 135. 135 plus a 25 over 10. 135 plus a 25. 125 plus a 25 would have been 150, so it's 160. 160 over 10, voila, what do you see? 16,000. Now let's do the same exact thing. Ask ourselves, what would the exact ratio have to be in order for the overall average to be exactly 17,000? And we're going to do the same thing again. We're going to assign it a weight of W, and we're going to have W plus 1, and now it has to be 17,000. Let's solve for it. 15W plus 25 equals 17W plus a 17. So solve for W, you get 2W equals to say 25 minus 17, which is 8, and W equals 4. What do you know? This works out very nicely. Now let's verify, shall we? We're claiming that in order for the overall average to be $17,000 in such a scenario where we have more than thrice as many people in department X as in Y, and if the average for department X is $15,000 and the average for department Y is $25,000, then in that case we are claiming that in order for the overall average to be exactly $17,000, we need a ratio of 4 to 1, which makes sense, because if the ratio is 4 to 1, which fulfills the condition. The condition was that there are more than thrice as many. They don't tell you exactly how many, there's more than thrice as many. So if you have 4 to 1, that's more than thrice as many. Let's verify, shall we? We're going to substitute 4 in here for W. So 4 plus 1 is 5. And that average has to be 17,000. Let's see if it is. 15 times 4 is 60. Plus a 25 over 5. And this gives us 85 over a 5. And how much is 85 divided by 5? Again, how do I know? Asking me a silly question. 8 divided by 5. How many 5s in an 8? 8 has 1 5s. 8 has 1 5s. The remaining 3 goes and joins the 5, becomes 35. And 35 divided by 5 is 7. Voila, what do you know? That's exactly what we have. So it works out. Everything works out. Everything is fine. Everything is, as we say in the desert, hunky-dory. I will see you tomorrow, okay? Bye now.